We are hearing some sounds on please.
All right. Union operation. You can see now the union of set A and B is the set of all elements which belongs to A or B or both. Now look at the diagram. Can you see the shaded portion?
Yes, sir.
Yes, sir.
A union B means everything that has to do with A and everything that has to do with B together. You're adding them together. Is that okay?
Yes,
Yes,
sir.
sir.
That's what you can see here. But you will not repeat any number. You will not repeat any letter. You will not repeat any sets. Or you will not repeat any element. Is that okay?
Yes,
Thank
sir.
you. Now, the next one is called the intersection.
Intersection.
But let's first of all exhaust the union. Now, when you say union, go to example 1.2. You have X, capital X as A, B, C, D, and T, F, H, D, G. Then what is X union T? What is the union of perform operation of union on set X and U, which is called S union T? What is the answer now? Everything in S, A, B, C, D must be there. A, B, C, D. Can you see it?
Yes, sir.
Yes, sir.
Then in T, you have what? F, H, D, G. So put F, H, D, G. But I told you there should not be repetition. D is coming twice. So you remove one and put only one. Is that okay?
Yes,
Yes, sir.
God bless you. So that is exactly what you, no letter is represented, is repeated. There are 4 letters there are 4 letters. So you're expecting 8 letters. But because D is repeated, you have to use only one. So when you say S union T, this is what it means. Now, likewise, you can also have another example. The set of real numbers and Q, set of negative real numbers. The union of the two, union of P and Q, consists of all real numbers except 0. Then, are you there?
yes, sir.
Yes, sir.
May also be defined, and you can also define A union B as X. The second is remove it, is such that, put such that this X. The first, hello, A union B is equal to, open the bracket, S. The next thing is such that, X, element of A, or X, element of B, bracket closes. You understand that? Thank you. Take note of that correction. There should be such, take note of that here. Now, there are other further remarks that we want you to know now. A union B is written as B union A. Why? Because they are commutative. Set A and set B are commutative under the operation of union. They are commutative under the operation of union. What is commutativity? Let's go to real number theory so that you can understand better. 1 plus 2 is what?
3.
Okay, interchange 1 and 2 now. 2 plus 1 is what?
3.
Pardon? 1 plus 2. 1 plus 2 is 3. 2 plus
Yes,
1
sir.
is what? What is 2 plus 1?
It's 3.
3 is 3, sir.
So when you interchange the numbers under the same operation, you are still having the same answer. It means they are commutative. 2 times 4.
Yes, sir. Times 4 is 8, sir.
4 times 2
8, sir.
is still commutative under addition. Under what? Addition. Now, 4 divided by 2. Addition is an operation. And division is also operation, isn't it?
Yes, sir, it is.
Operation on numbers. So 4 divided by 2.
2.
Then interchange 4 and 2. 2 divided by 4.
Minus 2, sir.
2 divided by 4.
Minus 2.
Minus
2
2.
divided by is minus 2, sir.
If your answer is minus 2, then you don't have the reason to be in the university. 2 divided by 4.
It's
Minus 2.
2 divided by 4.
0.5, sir.
Good. 2 divided by 4 is 2 over 4. 1 over 2, which is 0.5. Is that okay?
Yes, sir.
Before it's interchange, your answer was 2. When you interchange, the answer is 0.5. Is it commutative?
No, sir.
Is it commutative?
It's not, sir.
No,
No, sir.
sir.
No, sir.
Oh, good. I took you to number theory. So relate it to set theory now. So in set now, I want you to draw up some set of some sets. It can be at your time. Just say set A is 1, 2, 3. Set A is 2, 4, 7. Just pick something like that at random. Give set B something too. So operate A union B, B union A, and find out if you have the same answer. And it means they are commutative. Otherwise, they are not. Is that okay? That is one. Then another operation, another remark. When you have A and B, when you have both A and B are always subset of A and B, that is, hello? Hello?
No, sir.
Yes, sir, I can hear you.
You now understand A union B now. You understand A union B very well now.
Yes, sir.
You believe now that A is a subset of A union B. Do you agree?
Yes.
A is contained in A union B.
Yes, sir.
Likewise, B is also contained in A union B. Do you agree?
Yes.
Yes, sir.
Thank you. So, yes. So yes. Thank you. Fine. Good. It means fine. Good. It means thank you. That's another remark. That A is contained in A union B, and B is contained in A union B. There is no contention about that. All that is clear. And what law is that? That's another law. What law is that? It's called distributive law. It's called what?
Okay.
Distributive law.
Distributive law. Now, I wish we are in the class properly. I will have taken you to mathematics class and give you 1 or 2 examples on that. But it's okay. Let's go to intersection now. Intersection is another operations on set. You operate intersection on set. What is intersection? Intersection is simply the element that is common to both. Element that you can find in A and B. There is no between and or. There are 2 things, mind you. When you're using union operation, you make use of or. When you're using and, you make use of. When you're using intersection, you use and. Am I communicating? Am I communicating?
Yes, sir.
Yes, sir.
Thank you. So the Venn diagram is as seen now. You can see. This is set A. Can you see the whole ball? Set A. This is set B. If you look at them very well, they intercepted. Can you see the point of interception?
Yes, sir.
that point where they intersected is referred to as intersection of A and B, which is contained in A union B. Am I communicating?
Yes, sir.
So A intersection B is also contained in A union B. Take note of that. A intersection B is contained in A union B. Let's
Yes,
go
sir.
to an
Yes, sir.
example now. Now look at example 2.2.
Okay, yeah, no problem.
So can you come again now?
In which one? Ade, can you unmute yourself? Ade, you are disturbing us.
Can you go back, sir? For that
Pardon?
intersection.
Intersection. Can you see the intersection? Can you see the point we call intersection now? Intersection now. Now, example 2.2. Now, example 2. Let S be ABCD. Let S be ABCD. Then set T to be FGDG. What is the S? What is S union T now? You have BD. Can you see that?
Intercept 2.
What is common to S and T is D. Is that clear?
Yes, sir.
Is it
Now,
S intersection T or S union T?
this is S
Yes,
intersection T. Intersection is
Okay.
big head N. Intersection is
Okay.
big head N.
Move yourself, I beg. Move yourself, I beg.
All right. Now, example 2. Please kindly remove yourself so that others will understand.
Yeah, we don't.
Now, example 2.3 now. We have our set V to be 2, 3, 6, multiples of 2. Something is wrong there. What is wrong with that question?
Wrong with that question.
3 is 3 multiples of 2.
No.
Is 3 multiple of
No,
2?
sir.
No,
No.
sir, no, sir.
Change that 3 to 4.
4.
Change that 3 to 4. It's topographical error. So the set V is going to be 2, 4, 6, and
6.
so on. Is that okay?
Yes, sir.
Now, this dot dot means that
Yes,
it is it is what? It is it is what? Can somebody help me?
Infinite.
Infinity.
Infinite, sir. Infinite.
Infinity.
God bless you. Infinity. And it is defined. Is it not defined? Multiples
It is,
of
sir.
2 means it's defined. This dot dot
Yes,
dot
sir.
means it is
Okay.
infinite. So what are the lists now? 2, 4, 6, 8,
8,
10,
10, 12,
12,
14,
14, 16, 18, 20,
20.
22, like that, like that, like that. Good.
Yes, sir.
Let W now be what? 3, 6, 9, like that. Multiples of 3. What are multiples of 3? 3, 6, 9,
8, 6, 9, 11.
12. Who said 11?
12.
Who said 11?
Yes, sir.
Who said 11? You have committed murder to
Yes, sir.
mathematics.
Yes, sir.
Is 3 a multiple of
9,
11?
12, 15.
Or
No.
is 11
No,
multiple
no,
of
no.
3?
It's 8, 6,
No,
9,
sir.
12, 15.
Please, oh, I can sue you to court for destroying mathematics. So you have 3, 6, 9. Let's do 3 times 1, 3. 3 times 2, 6.
6.
3 times 3, 9. 3
9.
times 4, 12.
12.
3 times 5, 15.
15.
Can you see it? That's how you go on like that, like that, like that, like that, like that. I wish we were in the class. I would have taken you to number theory. So you
Yes.
see the beauty of these numbers like that. Now the question is now, then find the intersection of V and W. What are you expecting? What is common to both? Multiples of 2 and multiples of 3. What is common? 6, 12, 18.
18.
Which other one?
24.
24.
Mm.
Before 24, can anyone go before 24?
No.
No, fine.
No, sir.
24. After 24,
30.
30.
30. Yes. 30 can go. Why? 2 can divide 30. 3 can also divide 30.
Yes, that's it. Yes.
36. Great. You are getting it now. 2 can divide 36. Likewise, 3 can divide 36. And so on like that. Is it okay?
Yes, sir.
But if I were you, I would just expand my V. I will expand my W, maybe for 4, 5, or maybe for 6 letters, right, to allow me to do this well. Is that okay?
Yes.
Yes, sir.
Now, how do you now build for the intersection now? A intersection B could be regarded as what? Set of X such that, correct this now, rewrite it very well. Open the bracket. A intersection B is equal to X, is equal to open bracket. Have you done that? Open bracket. Have you done that?
Yes, sir.
X such that X element in A and X element of B. Then you can close the curly bracket now. Please correct that, please. It's topographical error. Is that okay?
Yes, sir.
Is that okay? Did you capture that?
Yes.
Please come again, sir.
Please come again.
All right. A intersection B is equal to bracket open X such that X element in A and X element of B, curly brackets closed. That is the definition. If you give anything other than that definition, you failed it. Is that okay? What is in your test is a topographical error. Just rewrite it. Thank you. You can see it said here the comma has the same meaning as and. No, you must put your hand there. You don't need comma. Put and. If you put or there instead of hand, it becomes a union of the two. Is that okay?
Yes, sir.
That's the difference between the definition of union and intersection. All right. Let's further look at the remarks now. When you are performing the operation of intersection on two sets, are they commutative? Is A intersection B equals to B intersection A? Is A intersection B equals to B intersection A? Try that on your own. That's the assignment I gave you yesterday. The second remark as well. The second remark, A intersection B is a subset of A. True or false? A intersection B is contained in A. Do you agree?
Yes, sir.
A intersection B is also contained in B. Let me set this example for you. Let me use this example for you. Like we have two families now. We have family of who is this? Oluwatosin Ade. Ajibola Emmanuel. Ajibola Emmanuel has a family. He's the husband, he has a wife, and he has children. Then Tochukwu Iya. Tochukwu Iya, you also have a family. You have a man, you have your wife, and you have children. These are two separate families. Do you agree with me?
Yes, sir.
Yes, sir.
At this
Yes,
joint,
sir.
you are disjointed. You have nothing in common. You have nothing in common. You have no blood relations, nothing in common, isn't it? You are two separate entities. But if Ajibola crosses with Tochukwu's wife, you produce a child from it outside wedlock. You call that child a bastard, isn't it?
Yes,
Yes,
sir.
sir.
Now, these two families now, they are no longer disjointed. They are jointed now by that bastard. Do you agree with me?
Yes, sir. Yes,
That
sir.
bastard is a member of family of Ajibola, and it's
And
also a
Tochukwu.
member of family of Tochukwu. Do you agree with
Yes.
me?
Yes,
Yes,
sir.
sir.
So that bastard is what we refer to as intersection now. That is intersection. That is where the two are jointed together. That is where the two families are jointed together. What belongs to the two families? Is it understood?
Yes, sir.
Yes, sir.
Great.
Very, very
But
nice.
when we said, take another remark in this case now. If they have no common elements, if they have no bastard, then the intersection of disjointed set must be a null set, must be an empty set, must be void. Do you agree with me?
Yes, sir.
Yes, sir. Yes, sir.
No area of intersection, no area that you have jointed. It means, and we are talking of set, operation on set. When you are talking set, an empty set is allowed, is regarded, isn't it? A void set is regarded, isn't it? Nothing like
Yes, sir.
zero. Zero is a set, one elemental set. It's not null. If you ask to define a null set and you are putting zero, it's a lie. Zero is a number. Are you with me?
Yes, sir.
Are you with me?
Yes, sir.
Yes,
Take
sir.
another remark. If a set, if set A and set B have no element in common, it means set A and B are disjointed. And the intersection of two disjointed sets is a null set. I can frame 2 or 3 questions from that area for you now. I can ask you to find,
Love it, sir.
please. That person should take care of that baby. Yakubu, tell your wife to take that baby out, please.
Okay, sir.
Your baby is disturbing us. Ibrahim,
Yes, sir.
tell your wife to excuse you with the baby, please.
Okay, sir.
Thank you. Or you mute yourself.
Okay, thank you, sir.
All right. Then there's another set. There's another operation, the operation of difference. Difference. When difference of set A and B is a set of elements which belong to A but do not belong to B. And it's referred to as A minus B. A minus B. That is what you can find in A but does not belong to B. Let's go back to that example the other time. That biometrics example of two families, family Ajibola and that. Set A, family A and family B. The difference of that set. The difference of that set is what? Ajibola
The difference is
and
the
wife
family, sir.
and children without the bastard is now referred to as A difference B. Am I communicating?
Yes, sir.
Difference is the bastard.
No, the difference is not the bastard. The difference is the family.
The difference is
without
not the
family.
bastard. The difference is minus anything that obstructs A. Anything in A that can be found in B
Come on, yeah.
Yes,
should
sir.
be
Okay,
removed
it's the
from
family.
A, which reads A minus B. Example of that again. Let's go to number theory. I have to take you to number theory because you are used to number from primary school, isn't it? We are now treat numbers now. Now, you have set of real numbers. Capital letter R is the set of real numbers. Do you agree to that?
Yes, sir. Yes, sir.
And we normally use capital letter Q to represent set of rational numbers. Set of what? Rational numbers. Now, remember, numbers can be rational or irrational. Numbers gives you real numbers. So what is the difference between real number and rational number now?
It's
If you
irrational
get
number,
it,
sir.
500 naira for you.
Irrational number, sir.
Irrational numbers.
God bless you. Irrational numbers. That is set of real numbers minus rational set of rational numbers give you set of irrational numbers.
Irrational number. Yes, sir.
Great. So what's your name now? 500 naira for
Confidence.
you. Take your account
Thank you, sir.
number.
Thank
Or you
you,
take
sir.
it
I'm typing
offline.
it.
Take it
I'm
offline.
typing it, sir.
All right. Now
Let's type it
you
now,
cannot write it this way. A minus B, that is A difference B is equal to bracket open X such that, correct that again, such that, not SX, X such that X element in A and X is not an element in B. That element in, when you cross it, it means not an element in. Is that okay? Can you see this? Can you see what I'm pointing to?
Can you repeat it?
Pardon? It means not an element in B. X is not an element in B. That's why you see that cross. Am I communicating?
Sorry, sir. I can't see your pointer, sir.
You can't see my pointer.
Oh.
All right. Okay. Go back to that. A difference B. Are you there?
Yes, sir.
Yes, sir.
Is equal to bracket open X.
Such that.
Good.
Hello, sir. We can hear
All
you.
right. Are you okay?
Yes, sir.
Now,
Okay.
remark now. Remark. Not anybody wants to. All right. Sorry about that. Now, remark 2.6. Let A difference B is also contained in set A. Do you agree with me?
Set A difference B.
It's contained in A. Think about it.
Yes, sir. Yes, sir.
Don't
Yes,
say
sir.
yes, sir. Don't say yes, sir. Just get it clear. I want you to, go
I
back
understand,
to
sir.
the drawing and see. A without B is contained in A.
Yes, sir.
Do you agree?
Yes, sir. Yes, sir. Yes, sir.
Yes,
It is,
sir.
sir.
I don't want you to agree with me in principle. I want you to agree with me in reality. That
Should I explain
yes,
it,
it's
sir?
realistic.
Should I
I can
explain it,
see. It's clear. Okay, good. Now, let's go to another remark now. To set A without B, A intersection B, and B without A, they are mutually disjointed. They have nothing in common. They are disjointed. And intersection of two disjointed sets is what?
Also,
The intersection
An
of
empty set.
is null.
Yes.
Sets.
If you find the intersection of these two sets now, that is bracket open A minus B, bracket close, intersection,
Hello, sir. It's not.
bracket open A, intersection B, bracket close, is going to be a null set. Do you agree?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Great,
I agree, sir.
great. If you intersect the three, you can see as A without B, intersection, A intersection B, intersection B minus A. The answer will still be what?
A null set.
Null set. Take note of that. Very, very essential. Now,
Yes, sir.
in some books, you can see they write A/B or A minus B. It's still the same thing. A difference is the difference of A and B. It could be written as A/B or A minus B. Am I communicating?
Yes, sir.
Yes, sir.
Thank you.
Yes, sir.
I can go further.
Thank you, man.
Now, we have another remark. The union of any set A is its complement.
Yes, sir.
And its complement is called a universal set. That is A union A complement is a universal set. What is complement of a set? A set that is not contained in another set is referred to as the complement. A set outside the set is called the complement. Is that okay? Let's go to biometrics now. Biometrics. Now, when we say a family, what is the definition of a family? A husband, a wife, and children. What of grandma at home? What of yourself?
It depends. If
They are
it's pretended
complement of a family. Grandma is a complement of a family. Househelp is the complement of a family. They are outside the family. You understand me?
nuclear family, sir.
Yeah.
Yes, sir.
I'm talking of a monogamous family. You understand?
Nuclear family, yes, sir. I understand, sir.
Now I'm talking, you must be a polygamist, are you? How many wives have you?
No, sir.
Oh yeah, list your wife. He said build that form. That's another test for you. What's your name? Tochuku?
Sir.
The set of Tochuku's wife is bracket open X, such that X is what? 2 plus N, where N is an unknown variable. Bracket closes. All right, it's okay. Now, when you have when you find the union operation of a set and its complement, a universal set, it gives you what?
Universal set.
But when you find the complements, what is the complement of, what is the intersection of a set and its complement? It gives you what? A null set. It gives you a null set. You know, a set and its complement, they are disjointed. Are they not disjointed? They don't have anything in common. Isn't it? Complement means nothing. Complement is something outside a set. Something outside, anything outside a set is referred to as a complement. So, which means they are disjointed. And we have told you that the intersection of two disjointed sets, it's an empty set. Take note of that. That's why I said don't cram it. Know it. Am I communicating?
Yes, sir.
So that's why you have A intersection, A complement as what? Empty set. A union, A complement as universal set. Then, what is the complement of a universal set? When you say universal set, Universal set can be referred to as a parent set. We have dealt with that in our first lecture. It is set that contains all the other sets in question. So, what is the complement of a universal set? It's an empty set. Isn't it?
Yes, sir.
What is the complement of an empty set? Universal set.
The universal set.
God bless you. Don't cram it. Just take note of it. You can draw up a set. Let's set A be 1 to 10. 1, 2, 3, 10. Closed set. Then you can now try to look for complement of it and so on like that. You understand what we are talking. Let's take another remark.
Yes, sir.
When you are looking for complement of complements, you have the same set back. Hello?
Nice, sir.
Minus times minus.
Plus.
Now you have let's take this this way. 2 raised to power minus 1. Write it down. 2 raised to power minus 1. Are you there?
Yes, sir.
Minus
2 raised to power minus 1.
No.
You have written it.
2 raised to power minus
You have written
1.
it, Abi. Have you written it?
Yes, sir.
Great. Yeah, introduce brackets. Put everything in brackets.
Please come again, sir.
2 raised to power minus 1. Yeah, introduce brackets. Put everything in brackets. And put raised to power minus 1 again on that bracket.
Okay, sir.
So what is the answer? What is the answer?
Bracket 2 raised to power minus 1, bracket minus 1.
Good. 2 raised to power minus 1 times minus 1. Minus 1 times minus 1 is what?
Plus to 1.
Plus 1. So everything becomes 2 raised to power 1. 2 raised to power 1 is something as 2. So that is like you are saying 2 raised to 2 complement of a set. A complement bracket complement of that again. Complement of
Okay,
a
sir.
complement.
Okay, sir.
Complement of a complement. So that first complement will negate the second complement. You have the same number left. So a complement, complement of a complement is A.
Yes, sir.
On that example that I've given to you, 2 raised to power minus half, or raised to power minus half again. Do you agree with me?
Yes,
I
sir.
agree, sir.
Very, very interesting. Very, very interesting. It's interesting. Can we take another remark?
Sure, sir.
Yes.
The difference, that's remark 2.11. The dot of A and B is equal to the intersection of A and the complement of B. That is, A minus B is equal to A intersection B complement. I know you disagree with me.
No, sir, but I don't understand it yet. I'm trying to understand it.
Okay.
Yes,
The
but
proof,
I'm trying to
the
understand.
proof is down. Just check it down. There is proof down.
Okay. Okay. A minus
The proof is down.
element A and
Yes, it's such
A, let's go to the proof now. A without B
sir.
is equal to bracket open X, such that X element in A and S element, S not an element of B, isn't it?
Yes, sir.
Yes, sir.
Great, I like that. Now, equals to bracket open X, S element of A. If X is not an element in B, it means
Yes.
X is an element of B complement. Do you agree with? If S is not in B, it's
Yes,
B.
sir.
So change this one to S element of B. Remove that not an element of in the last one. So it's going to be X
Okay, it's
element
incorrect.
of B complement. Do you understand now?
No.
Okay.
No confusion.
And by the definition of intersection, this means A intersection B.
Complement.
Complement, sir. Intersection, B complement.
You can see a lot of check figure 2.5. Figure 2.5. Can you see B complement?
Yes.
B, A is inside of B. A and B are inside the universal set. That box, rectangular box, is the universal set. Can you see it?
Okay.
Yes, sir.
Yes, sir.
A is contained in B. And we are talking of B complement. B complement means this is the whole of B now. Everything outside B is referred to as B complement. Those are the shaded portion. Can you see it clearly?
Okay, sir.
The
Yes,
shaded
sir.
portion are the B complement. Those things outside of B. Y is inside of B. That's why A is also part of it. Is that okay? Can you check
Yes,
figure 2.6 now? A complement. A complement. Right. A is inside of B. So A complement means inside of B, there are still some things that are not inside A, and those ones that are removed. You can see
Complement
the
of
shaded
B.
portion now alongside of the B complement. Can you see very well?
Yes, sir.
Can you see figure 2.6?
Yes, sir.
You understand that?
Come
Yes,
again,
sir. I
sir.
understand.
Jacob, look up.
I
Look
don't
at
understand that, sir.
A.
I don't understand that, sir.
Sir,
Do you
come again,
understand?
sir.
Sorry, sir.
2.6.
We don't understand that. You don't understand that, sir.
Do you understand 2.6?
Both.
Both.
Yes,
I
sir.
understand it, sir.
Now, go back to 2.5. What is complement? Everything outside of B is referred to B complement. That's why you see this sign. When you see this sign, B prime, it means B complement. Or they can write a small c. They can say small c in some textbook. B raised to power small c. That small c is called complement. Complement is an operation under set, which means B complement means everything that is outside of B.
Okay.
Is that okay?
Yes, sir.
And look at it now. This is the universal set. Can you see the universal set?
Yes,
That
sir.
is the rectangular.
Yes, sir.
The different set is the set that contains all other sets in question. You have set A, set B. They are contained in the universal set. Can you see them now? Now,
Yes.
this
Yes,
is
sir.
B. The bigger circle is B. The smaller circle is inside of B, which is A. So everything outside of B now is the shaded portion.
B complement.
It's now referred to as B complement. Is that clear now?
Yes, sir.
It is, sir. It is.
Thank you for that clearance or your comprehension. Go to figure 2.6 now. Are you in 2.6 now?
Yes, sir.
Yes, sir.
We want to look at A complement now. A is a smaller set than B. A is contained in B. So
Yes, sir.
everything outside A now, or complement of A now, is the shaded portion you are seeing. So some part of B are involved with the universal set. Are you there now?
Yes.
So
Yes, sir.
that white A is standing alone. Every other thing aside A is called A complement. It's called A complement. Is that okay?
Yes, sir.
Thank you. God bless you. Can we go further?
Yes, sir, we can. Except someone else.
Exercise 1. You have to shade this A union B.
Hey,
Shade A union B. What happens to A? A is jointed. Is it not jointed?
Yes, sir.
it is, sir.
Thank you. What of B? What of B? What happens?
It's a complement of A.
They are not even jointed.
No,
This one, B is subsumed in A, isn't it? B is even contained in A. So A
Yes,
union B is everything. It's just a box.
Yes,
But
sir.
what happened to C?
they are not
They are
jointed.
disjointed.
A union B, guys.
They are disjointed.
Yes, sir.
So you paint A separately, you paint B separately. Nothing in common. What is the intersection of C?
Sir,
What is the intersection of this C?
Intersection of C is null, sir.
God bless you. Who is that person? What's your name?
Confidently.
What's your name?
Confidently, sir. Confidence, sir.
5 marks for you. 5 marks. Remind me. 5
Thank
marks
you,
for you.
sir.
Remind me.
Thank you, sir. Thank you.
They are laughing. They thought I won't give them.
Thank you.
No, we are happy, sir.
Hello, sir.
All of us want to answer the question, sir.
All right. Can you see the solution now? Can you see the solution now?
Yes, sir.
Yes, sir.
Just paint everything. That is what union means. Everything in
Yes,
A
sir.
or B or both. Can you try this? Let A be 1, 2, 3, 4. Let B be 2, 4, 6, 8. And C 3, 4, 5, 6. Are you there?
Yes, sir.
Yes, sir.
What is A union B? Everybody.
A union B. 1, 2, 3, 4, 6, 8. 1, 2, 3,
3, 4, 5, 6, 8.
No,
1, 2, 3, 4. Who is saying 5?
6,
Who is saying 5? A union B.
2, 5 is 1, 2, 3, 4, 6, 8.
1, 2, 3, 4, 6, 8.
God bless
1,
you.
2,
1, 2, 3,
4,
4,
6,
6, 8. Clap for yourself.
Yes, sir.
If you don't get it, don't clap for
Thank you,
yourself.
sir.
Now, what is A union C?
1, 2,
1,
2, 3, 4,
1,
2, 3, 4, 5, 6.
5, 6.
1,
1, 2, 3, 4, 5,
Bless
6.
you. God bless you. God bless you.
1, 2, 3,
A
4,
good
5, 6.
student. In fact, I'm going to give you a distinguished student now, because you distinguished student from now.
Thank you, sir.
Yes, you are distinguished students. What about B union C? B
2,
union
4,
C.
5, 6, 8.
2,
2, 4, 4, 5, 6, 8.
2, 4,
2, 4,
2, 4, 5, 6, 8.
2, 4,
6, 8.
2, 4, 5, 6, 8.
2, 4, 5, 6, 8.
2, 4, 5, 6, 8.
2, 3, 4,
4, 5, 6, 8.
Please,
No,
there is
2,
3. You
4,
throw
5,
3
6,
away.
8.
You throw 3 away.
2, 4,
2, 3,
2, 3, 4, 5, 6, 8. 2, 3, 4, 5,
2,
6, 8.
3, 4, 6, 8.
2, 3, 4, 5, 6,
2, 3,
3, 4,
4, 5,
3.
6, 8.
No,
2, 3, 4, 5, 6,
2, 3,
8.
4, 5, 6, 8.
Yes.
Thank you. All right. What is B union B?
2, 4, 6, 8.
2, 4, 6, 8.
Thank you. Which means B union B is also B.
Yes,
Do
sir.
you
Yes,
agree?
sir.
Yes, sir.
What is B intersection B now?
The demand is B intersection B.
It's 2, 4, 6, 8.
That is the same thing,
2,
sir.
4, 6, 8. It's the
2,
same, sir.
4, 6, 8. Yeah.
Yes, sir.
Yes, because it's what it has in common with itself. So, 2, 4, 6, 8.
All right. What's your solution now? Can you see the solution now?
Yes. You got it. Yes, sir.
Yes, sir.
All right.
You got it.
So that's the end of the lecture.
Thank you very much, sir.
Thank
you so much, sir.
We are meeting next. When are we meeting next? When are we meeting again?
When, sir?
Whenever you want, sir.
Okay. Can we meet? Can we meet? All right. Before our meeting, we are meeting next week. We have 2 lectures next week as well. Before meeting you next week, we are going to meet Tuesday and Wednesday as well. Is that okay by you?
Yes, sir.
Yes, sir.
Send us email, sir.
I will send you email. But before then, I will treat Unit 3 set of numbers. I will treat and send to you.
Okay.
Okay, sir.
You understand?
Yes, sir.
Set of numbers. I will treat and send to you.
Okay, sir.
You have the note already.
Yes, sir.
You have the note already. Unit 3. I'm going to do demo of it. I'm going to prepare a lecture on it and send it to your mail. You'll pick it up.
Okay, sir.
So that when we meet next week,
Okay, sir.
instead of using 2 days, we just use 1
One
contact
day.
hour, then the next class, like that.
That's nice, sir.
Thank you, everybody.
Thank you, sir.
John,
Thank you, sir.
Sir,
my John, you are not
I'll send
cooperating
you a
today. What
message,
happened?
sir.
much, sir. Thank you, sir.
You didn't cooperate today. What happened? Favor, you
Thank
didn't
you,
talk
sir.
today.
Thank you, sir. Thank you, sir.
Eh?
Thank you.
God
sir.
bless you. Nziri.
Okay,
All
sir.
right, bye-bye. Thank you, sir.
Bye.
Bye. Have a nice day, sir.
Thank you.
Did you enjoy
Take
your
care.
lecture
Thank
today,
you,
sir?
sir.
Because of network.
I'll send you a message, sir. You I should remind you. I'll send you a message, sir.
What message is that, please?
Hello, sir.
For 5
I
marks.
should remind you of my 5 marks.
For the 5 marks.
My 5 marks. And my 5 marks.
Emmanuel, wait.
It's competency, sir.
Ochuku, you are not doing your work. You are the class
Sir,
rep.
it's competency.
Give me the list of noisemakers, please. Ochuku,
Okay, sir.
Emma.
Sir, it's I should remind you for my 5 marks.
Yes, sir. I'll do, sir.
Right, bye-bye.
Bye-bye, sir. Thank you, sir.
Oh my
Favor,
God.
why? Favor, you are moody. What's the problem?
Hello, sir.
Imagine, you are moody. What's the problem?
My network
I will be
will
moving
not
next
allow me
week,
to enjoy
sir.
the lecture, sir.
I'll be moving next week, sir.
I have traveled. Where network is so poor that I couldn't enjoy the lecture, sir.
I'll
Sorry.
be moving next week, sir. If you don't give my 5 marks.
Favor, what happened?
Favor, what happened? Be cheerful. All will be well. All will be well. Don't worry. All will be well.
Okay, sir.
Be careful.
I said
Just go and
to
befriend Chidima. Chidima John. She's laughing. So go and be her friend. Take care.
Thanks,
sir. Bye.
Thanks so much. That's my account number, sir.
Okay, sir. Bye, sir.
All right, cheers.
Thank you, sir.
You know the account number.